1969 BC 32, whereas for what values of x does the series 1 plus 2 to the x plus 3 to the x plus 4 to the x plus n to the x converge? Now, this is kind of a tricky question here, and it's not easy for people to see originally. This is a p-series problem. You have n to the x. Where n goes from 1 to infinity, it's n to the x. And now ordinarily, if we had had a p-series would look something like this: n equals 1 to infinity of 1 over n to the pth power, right? Where we know that p has to be greater than 1 in order for that to converge. So we're not used to seeing x there when it's a p-series, but in fact that's no different than if we had had n equals 1 to infinity of 1 over n to the x power, right? So what we need here is we need p to be greater than 1. However, notice that the p is in the denominator there. So if we wrote this without a denominator, then we really would want p to be greater than negative 1, right? I'm sorry, we would want it to be less than negative 1. So, for example, if we wrote sum n equals 1 to infinity of n to the p power, you might say, well, that doesn't converge. But it could converge if p not greater than but is less than negative 1, because in that case you'd have 1 over n to the p, and p would be greater than 1 in that case. I hope that makes sense here. So what we're really dealing with here is a p-series, and we want our x value, just as the one I showed there, will converge whenever x is less than negative 1. When x is less than negative 1, you get n equals 1 to infinity of 1 over n to the x, where x is now greater than 1. Hopefully that's not too confusing and it makes some sense there. So your x value has to be less than or equal, just less than 1, not equal to 1, in order for that to be a p-series that converges. And hopefully that's going to make sense there. It is kind of a tricky problem the way that it's set up.